Hi class, welcome to Lesson 7 of Unit 1. In this lesson, we will start our exploration in the classification of matter. Today, our exploration will focus on pure substances. Today, you'll work to see if you can identify the two major types of pure substances, elements and compounds, and distinguish them by formula, property, and particle diagram.
In your guided notes, you've been given an empty flowchart like this. Make sure you put these notes in your flowchart. So the information for pure substances will go here on the left, and the information for mixtures will go here on the right. Today, we're going to focus only on pure substances. The next lesson will focus on mixtures. Pure substances are substances that can either be classified as an element or a compound. So if you look at the particle diagrams here for pure substances, you'll notice that each particle is identical. So on the leftmost picture, these blue dots are identical. Now, when we say particle, we kind of mean that things that are bonded or touching. So here, again, with these green particles, although they are not single particles, each item is identical. And then again here we have this more complex particle, but each of these parts are identical. Let's contrast that to mixtures. So here in these mixtures you'll see that the particles are not identical. In the first mixture we have the red and white particles. And in the second mixture we have these red-headed, white-eared Mickey Mouse-like particles and these single red particles. So pure substances have it where every particle that is present is identical. Now these particles could be elements or compounds. We'll talk about those shortly. Now you cannot break down pure substances by physical means because the particles, if they are combined together, will be chemically combined. Now, pure substances always have definite and constant composition. So, for instance, water is H2O, or 2 hydrogens and 1 oxygen, and hydrogen peroxide is H2O2, or 2 hydrogen and 2 oxygen. Different pure substances will have different formulas and different names and different properties. So again, today we're going to be focusing on pure substances. So that means we're going to be focusing on the left side of this flowchart. So you should have completed this bubble for pure substances. Mixtures will be blank until next lesson. And now we're going to look at elements and compounds. So we should add our notes in this area. Elements will be on the left and compounds will be on the right. Elements are the simplest form of matter. They are made up of one type of atom. They are characterized by a chemical symbol, and we'll see that chemical symbols always have one capital letter, and they may have no, one, or two lowercase letters. Since elements are the simplest form of matter, they cannot be broken down physically or chemically. Elements are classified as monatomic, mono meaning one atom, or diatomic meaning two atoms. And they may be metals, nonmetals, and metalloids. So here in the particle diagram, you can see that the different types of atoms are pictured in different colors. So in the leftmost particle diagram, here these pink dots each represent what we would call a monoatomic element because there's only one type of atom present. Now, over here, in these are diatomic elements. Now, this is still an element because we only have one kind of atom, the red atom, but it's considered diatomic because these atoms are bonded together. They only ever exist in a pair. For right now, let's focus on the properties of elements. We'll come back to compounds later in the video. So again, we remember that element symbols only ever have one capital letter, and they may have no lowercase letters, like in carbon, it is just a capital C. You could have two lowercase letters, like in copper, it's a capital C and a lowercase u, or we could have like elements on our reference table 111 to 118, they could actually have a capital letter and then two lowercase letters. Now, of all 118 elements that we know of, 7 of them are diatomic. What that means, as in nature, under standard conditions, they always exist in a pair. So when we write their symbol, when they are lone elements, always end in a 2. Now, when we get into compounds, these symbols do not have to have 2's, only in their elemental state. Now, there are some ways that you can memorize the 7 diatomic elements. The way in which I like to memorize is this mnemonic device that I learned a long time ago, and it's I brought clothes home from Old Navy. Notice that all of these element symbols have a subscripted 2 because they are diatomic, and they'll look like this in a particle diagram. Another way to memorize the 7 diatomic elements is to refer to your reference table. And here we'll begin at element number 7, nitrogen. And then we will make a 7. So here we have nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So here you can see this is in the shape of a 7. The only problem here is one element is left out. And as typical in most rules in chemistry, there's one exception. So you have to do the magic 7, so it makes a number 7 on the reference table. You begin at element number 7, but you're going to have to add in hydrogen way over here. Now here we can see a picture of our reference table that is color-coded. And we can see that the way in which elements are arranged on the reference table are so that the metals tend to be here on the left, and the nonmetals tend to be here on the right. And then in the middle we have these things called metalloids. Now, if you forget where the metals are, if they're on the left or the right, just find an element that you know is a metal. Most of us know that iron or copper or silver are metals. So we can find them and assume that immediately around them, that area is filled with metals. Now again, I had mentioned earlier that almost every rule in chemistry has one exception. So notice all of our nonmetals over here. There's one nonmetal that is not located on the right, and that's hydrogen. Hydrogen has some similar chemistry to metals, and that's why it's placed where it is on the reference table, but hydrogen is a gas and not a metal. Now, to identify the location of the metalloids on our periodic table, we're going to look on our reference table for this bold line. And elements that touch this bold line on 2 sides, so that means that you have to have both a horizontal and a vertical bold line touching your box, are considered metalloids. So here you can see that boron is a metalloid because it has both the vertical and the horizontal line. But carbon, which touches this bold stair step, does not actually have a bold line, so it is not a metalloid. So boron, silicon, germanium, arsenic, tellurium, antimony are all metalloids. Sometimes polonium and acetine are recognized as metalloids, but that is less common. Now, you should notice here aluminum is a little interesting. Aluminum does have 2 bold lines of this staircase touching it, but aluminum is an exception Again, I had told you earlier that for almost every rule in chemistry, there's one exception. I'm sure you're probably aware that aluminum is a metal, like aluminum foil or aluminum cans, so aluminum is not considered a metalloid. Now, why do these three distinctions exist? Because these three areas, these elements have very similar physical and chemical properties. So take a minute to write down the properties of the metals, and then we'll look at nonmetals and metalloids. Metals tend to be gray in color, shiny, which in chemistry we'll say that they have luster. Metals also tend to be solids at room temperature, malleable, which means bendable and that you can hammer it into a sheet. Ductile, which means you can pull it into a wire. So when we look inside of all of the charging cables for our electronics, we can expect to find metal wires. They are very good conductors of both heat and electricity, and they have fairly high melting points and boiling points, especially when you consider them compared to all the other elements on the table, on the periodic table, that is. Now, metals tend to lose electrons or form positive ions called cations. When an object loses electrons, it is said to be oxidized. So rust is another word for oxidation. Nonmetals have much more varied properties because nonmetals have lower boiling points and melting points to the point that many nonmetals are actually gases and liquids at room temperature, though we know that solid nonmetals tend to be brittle or they easily crumble. They are poor conductors of heat and electricity. Nonmetals have the opposite behavior to metals. They tend to gain electrons during a chemical process. As they gain electrons, their charge is reduced because electrons are negative, and they form anions or negative ions. Now again, metalloids are really interesting because those are those elements that straddle the dividing line between the metal elements and the nonmetal elements. And with metalloids, they tend to have properties of both metal and nonmetallic elements, and it can be very dependent on environment. Now that we've finished talking about elements that could be metals, nonmetals, or metalloids, we want to talk about compounds. Again, we should place these notes in our flowchart that has been provided. Now, compounds contain two or more different kinds of elements that are chemically combined. So they have a chemical formula. Chemical formulas always have at least two capital letters. Sometimes they'll have numbers as well. Like here, we all know water is a compound. It is formed between the elements hydrogen and oxygen. Now, compounds can be broken down by chemical means, meaning a chemical reaction can break the bonds and separate the compound into its elements. Now, as we discussed earlier, compounds always have a definite ratio of elements. So water, which is really healthy for you, has the formula H2O, but hydrogen peroxide has the formula H2O2. So here we can see that a different proportion gives a different formula, a different name, and very different properties. There's this great chemistry joke that says, a man walks into a bar. He asks for H2O. He gets a cup of water. The man behind him asks for H2O2 and dies. Notice that in these compound formulas, we have at least two capital letters. We could have many more capital letters. Or in biology, I'm sure you learned about glucose, whose formula has three capital letters, C6H12O6. One really interesting
characteristic of compounds is their properties are entirely different from the elements that make them up. So when we look at water, water is made of hydrogen and oxygen elements. Hydrogen is a flammable gas, and oxygen is also a flammable gas, but bonded together as H2O, they form a substance that puts out fire. There's no way for us to be able to predict the properties of compounds from their elements other than from looking at the type of bond that will be present. We know that the bond could either be ionic or covalent. We'll talk about that more in a minute. Here, remember that compounds are still pure substances because when we see their particle diagrams, every particle within the diagram is identical. They just happen to have two or more different elements in each particle. Now, when we talk about compounds, we can classify compounds as ionic or covalent. The easiest way to distinguish an ionic compound from a covalent compound is ionic compounds contain a metal and a nonmetal bonded together. We almost always write the metal first. And covalent compounds contain nonmetals bonded to other nonmetals. So here are two examples of each. So ionic compounds contain sodium, element number 11, found on the left side of our reference table, and chlorine, element number 17, found on the right side of our periodic table. This is sodium chloride, also known as table salt. Magnesium chloride is another salt, as the word salt in chemistry actually means ionic. Magnesium chloride, though, contains the metal magnesium and two nonmetal elements of chlorine. Covalent compounds always combine two nonmetals. Carbon monoxide and carbon dioxide are both covalent compounds. Now notice that these two compounds contain the exact same elements, but in a different proportion. Carbon dioxide is relatively safe for humans, as it is the gas we exhale. Carbon monoxide, however, is an odorless, colorless, and poisonous gas that we'll always want to stay away from. The last thing we want to look at is how we can read chemical reactions which are written in shorthand. Now, when we look at chemical reactions, all of the items that we begin a reaction with, which will be located to the left of an arrow, are called reactants. And all of the items that we end a reaction with, that will be found to the right of an arrow, are called products. And we can read this arrow as yields or reacts with. Now, in a chemical formula, we have numbers of various sizes. We have these smaller numbers called subscripts. Those tell us the amount of atoms within the compound. The subscript always follows the symbol. So here in CH4, there is 1 carbon and 4 hydrogens. In chemistry, we don't write ones. But sometimes we have these larger numbers in front of a compound. These larger numbers are called coefficients, and these tell us how many of these formulas are present. So, for instance, where we have the 2 in front of the waters, that means we have 2 waters. So again, you can see the subscript tells us how the substance is put together at the atomic level, whereas the coefficient tells us how many of those items we have. So notice that when we have O2, that means I have 2 oxygens. But this 2 tells me I have 2 of those entire units. Again, we can see this with water. So water is H2O. So we have 2 hydrogens and an oxygen in 1 water. But this coefficient of 2 means that I have 2 water molecules. We'll practice looking at and reading
chemical reactions throughout the entire school year. It's important, though, we get a basic understanding now, as this is chemistry class. So for this formula, what we would read, and I'll use the best name possible for the covalent compound here, methane reacts with 2 oxygen and yields 1 carbon dioxide and 2 waters. That concludes Lesson 7, focusing on pure substances. See you in class.